Hi, in this lesson, we're going to talk about sound, and this is an introduction to the sound unit. So, what is sound? Well, basically, if I take this piece of paper over here, all right, and I sort of wiggle it, you guys can hear that, all right. I made some sound, all right? And essentially what's going on is this little piece of paper is vibrating back and forth. So it's vibrating back and forth very, very quickly. And what's happening is you are detecting the compression and the expansion of air or of the molecules. And that's essentially what sound is. So you have the energy in moving the paper back and forth really, really quickly. That gets transferred to a change of air pressure in the medium. It could be water pressure or anything, glass, steel, because those objects also transmit sound, and then you hear it. So if I do it really rapidly, as you can hear that, that is sound. All right, so let's write that down. Essentially what sound is, it is compression and expansion of any medium. All right, and for us, our main medium is air. So air molecules. You can hear sound in water. You know that other materials transmit sounds as well, like glass or steel, pretty much any medium. All right. And so essentially, if you have the piece of paper like here, and it is a vibrating, so we have a vibrating paper vibrating, okay, and it's going back and forth like so. Then let's say you have the air molecules, and so this represents air molecules, but hey, you could be, like I said, in water, and each air molecule for now is evenly spread out, okay, like so. I think that's enough air molecules spreading out, okay. And what happens is the paper, as it moves forward, it compresses, and then when it moves back, so it moves back and forth, it leaves a gap kind of thing. So when it moves forward here, you're going to have a compression of these air molecules, okay, and then when it moves back, you're going to have a little vacuum created or an expansion. And so they happen at regular intervals. And so then what happens is you detect it. The eardrum basically detects really different air pressures. Okay, that's why when you're on an airplane, your ears, when they like to pop and they can't hear as well because the pressure difference, it sort of stops the eardrum from vibrating completely. All right, so right now I'm just drawing these molecules that have been compressed together in a sense, and then you have like the gaps in between. All right, and that's essentially what sound is. Okay, so here is your compression, okay, and then in between is called a rarefaction, like so. And then because typically the vibration happens very quickly but at regular intervals, you can actually physically measure, if you want, between compressions, and we give that a name that's called wavelength or lambda. Okay, so let's say from the middle of the compression to the middle, we'll call that lambda. It's the Greek letter. All right, it looks like an upside down Y, and that's called lambda, and that represents wavelength, for example. And that could be measured from the middle of the compression to the middle of the compression, or it could be measured from, let's say, the end of one compression to the other end, or the beginning of one compression to the other end. It's essentially the distance between compressions. the distance between compressions. Okay, perfect. Now, knowing that you need a medium to produce sound, is there sound in space? Well, there is no medium because in space it's a vacuum. So that means there is no sound at all. So when you hear, I guess, movies that have fight scenes and things exploding in space, in real life it would actually happen in silence, but that's a pretty boring movie. So that's why they throw in the sound. All right. So there is no sound. No sound in space because there is nothing to vibrate. All right, so we talked about paper vibrating, and that's how sound is created. So let's talk about the next sort of concept. So we talked about the distance of compressions. That's great. But how quickly does something vibrate? And that's called frequency. So that's our next little, I guess, topic. All right, frequency. So essentially the speed of vibration, all right? How fast does something vibrate? How fast does something vibrate? Is sort of like a frequency kind of thing. And anything can actually vibrate, or there could be, any frequency can describe a repetitive motion, okay? So let's do an example right now. I'm going to take my marker here, and I'm going to be really annoying, and I'm going to tap the table very quickly. Okay, that's kind of annoying, isn't it? We're going to calculate the frequency of vibration for that, okay? So we have the frequency of vibration. So here's an example. Okay, the example would be, let's say Mrs. Trache taps on the table with her marker at, let's say, or four, we'll say four, for 220 taps. So let's say I do 220 taps in 1 minute. In 1 minute. Let's do that, okay? So to calculate the frequency, here's the formula. Frequency, which is often written as a letter F, a little f, so a little f, is equal to the number of taps or items, okay? Taps, you can say cycles or number of stuff, okay? Because frequency can be described for a lot of many things that repeats over and over again, all divided by the time it takes. And typically that's measured in seconds, but you can do minutes if you want, like revolutions or circles per minute. That's called RPM, all right? So it doesn't matter the time. Depending on the subject matter, you can decide if it's seconds or minutes or hours, okay? And so that's sort of the formula. So in this case, we have 120 taps divided by, let's do it in 1 minute, for example, and so this will be, the frequency is 120 taps per minute, okay? But let's say you want to do it in seconds. So we can also do it 120 divided by 60 seconds, and that will give me 2 taps per second. Taps per second. Now, actually, there's 2 taps per second. There we go. Actually, there is a unit for seconds. It's called hertz. So this would be technically 2 hertz. Okay, so hertz is always measured in seconds. All right, so let's sort of highlight that. Always measured in seconds. Okay, and so basically the answer here, what is the frequency of this, is, well, I am tapping at 2 hertz. So I am tapping my marker on the table for 2 hertz. And I just realized that I need to write ER for marker. Okay, perfect. So I am tapping my marker on the table. I shouldn't say for 2 hertz. I should say at 2 hertz. My apologies. So at 2 hertz. Okay. Okay, so now that I have been tapping my marker on the table at 2 hertz, okay, here's another interesting time question. Instead of how many taps there are in an amount of time, let's say in a minute, you can also ask how long between taps, or how long is each tap. And that's also a measure of how fast a marker is tapping, right? And so we measure that in another way called period. Okay, so with period, it's very similar to frequency, except it could be described as how long between taps. Okay, so period, because it is a time, because you're trying to describe the time or how long something takes, we have T, okay, for example, for period, and that is going to be the amount of time the item that you are timing takes, divided by, again, the number of taps or cycles or stuff that is repeating. Okay, so then in our example here, the time, let's say for 1 minute, this would be 1 minute, and the number of taps is 120 taps. And so in this case, if you divide that, let's actually convert it to seconds. All right, so we have 60 seconds, 120 taps. That means it is going to be 0.5 seconds per tap. Okay, so there are 2 ways how to describe a vibration. All right, there are 2 ways to describe a vibration. So let's describe. Okay, so there are 2 ways to describe here. Let me just write that clearer for you. Describe. There we go. A vibration. One of them is frequency. Okay, so frequency here, again, is the number of stuff over time. All right, so it could be taps, or it could be cycles, or vibration of the paper back and forth. And then the other type is time over the number of stuff that you're doing, that repetitive motion. You'll notice these are reciprocals of each other, all right, or inverses. So you can actually write the formula like this. If you happen to know the frequency, let's say, then you can actually, if you happen to know the time, then you can inverse the time to get the frequency. Also, if you happen to know the frequency, then you can inverse that, and then you will get the time. Okay? So for now, we know how quickly something vibrates. Typically, in sound, we measure the vibration in frequency in hertz, all right? But once in a while, we might want to measure it in time or periods. Typically, we don't do that though. We usually stick with the vibration. All right, so you probably need a little practice going back and forth. So our next sheet here is sounds, vibrations, period, and frequency. Okay, and so here are some different things that you can practice, like a sewing machine needle that goes up and down, or a pendulum swinging, or let's say you eat a bunch of jelly beans. And so have fun with that sheet, and then we'll see you next time on more lessons on sound. See you then. Bye.